In this video, I want to talk about the refrigeration diagram worksheets that are found in the air conditioning course. Now, when you look at the worksheets, they are black and white, so you do have to a little bit realize how they're set up on high and low pressures, but it is the refrigeration cycle. Okay, each one of these points is a temperature pressure point. So we have one temperature pressure point on the discharge line. We have one temperature pressure point at the inlet of the, well, on the sort of the first pass of the condenser. We have another temperature pressure point as in the last pass of the condenser. And then you have another one on right before the metering device, which is a TXV. You have another one right after the metering device. And then we have one as we're leaving the evaporator and one on the suction line. So what we've done is we've added a couple temperature pressure points to the whole thing. Now, when you talk about a refrigeration cycle, you have to remember certain basics that we seem to forget occasionally. So let me draw some lines in here. Okay, so when we go here, okay, let me just get my line here. Okay, we have a point of pressure change. We have 2 points of pressure change in the entire system. Okay, if I take a line and basically, and I'm going to move this around a little bit, and if I draw a line through here, everything on the right side of this will be low pressure. Okay, and just to make this easier, let me go ahead and change my font color. Okay, so everything on the right side of that is low pressure. Everything on the condenser side of this is going to be high pressure. So again, let me just make that red so it becomes easy. Now, no matter where I put my gauges, unless we're dealing with a very long condenser or a very long evaporator, okay, any place where I put my gauges, the pressure's going to be the same on the high side, and any place I put my gauges, the pressure's going to be the same on the low side. What changes in different places is the temperature. And just remember, TP4, even though the line goes right through it, it is actually on the high side because it's on the left side of the metering device. Okay, so when we're looking at this, you need to look at these diagrams and realize, again, the basic rule is that no matter where you put your gauges, if it's on the same side of the compressor and the metering device, the pressures are going to be the same. If you put gauges on the low side, no matter where you put them, the pressure is going to be the same because it's all based on the evaporator temperature. On the condensing side, on the high side, no matter where you put your gauges, the pressure is going to be the same. What changes is the temperature. So when we look at this diagram, okay, we have our high side, low side. Now, the other thing you have to realize is we have a change of state going on. Change of state, all I'm talking about is the change from a liquid to a vapor or from a vapor to a liquid. Okay, let me just click off of that line and I will come in and we're going to add another line. Okay, I'm going to use green in this case. So someplace, okay, and again, this is sort of a rough translation, okay? But someplace in this area, okay, in the condenser, by the last pass of the condenser, actually it goes this way. Let me pull that down a little bit. And by the last pass of the evaporator, we have completely changed state. And we come out of the compressor as a high pressure vapor. We de-superheat. We start to condense, and by the time it comes out of the condenser, it's a liquid. As we come into the evaporator, it's a flash gas, which is actually a low pressure liquid. Then we come in, we boil it off, absorb heat, and by the time we're in the last pass of the evaporator, we should be 100% vapor. coming back to the compressor. So when we look at this diagram, everything below the green line, okay, everything below the green line is a liquid. Everything above the green line is a vapor. Now, we've already gone over this in the refrigeration cycle, but when you're looking at these worksheets, this is where it becomes important. Okay, so we have a refrigerant R134A. Okay, that's over here. It's R134A. Now, what we need to do is we need to find out what things are at these different points. Okay, we know some numbers are given. Okay, so if TP2 is 135 pounds, okay, that's what we're being told. TP2 is 135. Every pressure reading on the same side of my metering device and my compressor is also going to be 135. So if I go in here, I have 135. Okay, TP3 is on the same side, it's 135. And TP4, okay, is right there, it's 135. Now, if I come over here, and I'm just going to change font color just so to make this easier to get. If I come over here, I'm being told TP5 has a pressure of 35. That means that TP6 and TP7 will still have a pressure of 35 because the pressure remains the same no matter where you put your gauges. Okay, so we know that TP3 has a pressure, okay, of 135. TP4 has a temperature of 96. Okay, so that's right there. But that means we have subcooling. We know we do not have any superheat. We have superheat at TP1, but at TP2, we do not have any superheat anymore. Okay, and I'll explain that in a minute. But on the high side, we don't have superheat once it goes into the condenser. So we might as well just put in, I'm just putting in a dash. Okay, on the low side of the system, which is TP5, TP6, and TP7, I do not have any subcooling. So you might as well just get that out, and we're going to say we don't have any subcooling. Okay, because we're not worried about subcooling there. Okay, so now we have to do some temperature pressure conversions. So again, we have 134A. Okay, I'm going to come over to a TP chart that I already have opened. I want to find 134A. Okay, and let me just blow this up a little bit because it's tough to see. So I have 134A. Okay, I have a pressure of 35. Okay, so when I take my pressure of 35, let me just circle that. Okay, that tells me my temperature is 40. So let's go back over to the worksheet. Okay, my evaporator temperature is 40. Okay, so I'm going to come in here. Okay, TP6 we're going to say 40, and TP5 we're going to say 40 because that's pretty much going to remain the same. Okay, now at TP7 I have a temperature of 54. Which makes sense because in the last pass, we start gaining superheat. Remember, that's my sensible heat increase. So I have a superheat I can put in here of 14. Here I don't have a superheat, and here I don't have a superheat because we're still doing my latent heat change all the way to that point. Okay, now, over here, we need to find my temperature of 135 is my PSI. So let's come over here to my sheet. I need to come down here and I need to find 135 PSI. which equals, it's right there. Okay, which equals 105 degrees. So remember, that is the temperature of my condenser, is 105. So let me go ahead and put the numbers in. Now notice I'm not putting it in the first column. I'm doing it over here, okay? And there's a reason I'm doing it over here. Because if I have a superheat of 50 degrees, that means my temperature here is 155. Remember, one of the functions of my condenser is to de-superheat. So I have superheated vapor coming out of my compressor into the first pass or passes of my condenser. It's going to de-superheat. So I'm going to drop the 50 degrees of superheat, and I'm going to bring my temperature down to the 105 degrees, which is my condenser temperature. Now, we also have subcooling we have to worry about. Now, subcooling does not happen until the refrigerant leaves the condenser. So it happens between TP3 and TP4. So as we leave the condenser, I have my subcooling. Okay, so we take our 105 degrees and subtract 96. So we have 105 minus 96. So I have 9 degrees of subcooling there. Okay, makes sense so far? I hope so. Now, down here, it's wanting to know what the state of the refrigerant is as we're at each of these points. Okay, at TP1, it's coming out of the compressor. So we know it's a gas. TP2 and TP3, we can say saturated because it's sort of and TP4 or TP3, you could either say liquid or saturated. It's sort of right at that line. So I will probably check both because it could, exactly where that line is questionable. So we'll come down here and we'll say both. TP4 going into my metering device, we hope it's a liquid. If it's anything else, we have a problem. Okay, now coming up here let's come back over to TP5. Okay, TP5 is actually something we call flash gas. So it's sort of a combination of liquid and gas because it's a low pressure liquid that is sort of flashing off as it leaves the metering device. TP6, again, I am going to say sort of saturated. It could also be, some people will say it's a gas. Either way, it's fine. So you can come in here, do that. And coming into the compressor, it is definitely a gas. Okay, we don't want any liquid coming into the compressor. So all we're doing is looking at these worksheets and saying, okay, where are we in the refrigeration cycle, and do we understand the differences in the temperatures and the fact the pressures remain the same all the way through one side of it? So having done that one, I'm going to skip, let's just do number 4. I'll leave you guys to do 2 and 3 on your own. So 4, again, we have the same thing. If you want to, we can draw in our line so we understand let me come in here and I'm going to just draw my saturation line. Okay, remember everything below that is a liquid, everything above that is a gas. We'll draw in my points of pressure change. Okay, 2 points of pressure change, metering device and compressor. Okay, this just for some people this makes it a little bit easier. Okay, let's look at each point. Let's find out what it is first. Okay, coming out of the compressor, we know it's a gas. Okay, coming into the condenser, okay, I'm going to go saturated there. And down here, it could either be saturated or liquid. TP4 better be a liquid. Okay, because it's right there. TP5, it's sort of a combination of liquid and gas. I hate using saturated for it because you really need to know it is really a low pressure liquid that is flashing off right away. TP6, depending on exactly where that arrow is, it is either saturated or gas. And TP7 better be a gas. We do not want liquid under any circumstances coming back to the compressor. Okay, let's come up here and take care of my pressures. We know that my pressure at TP4 is 169. The pressure does not change on the entire high side of the system, so we can fill all of those in. Okay, TP7, my pressure is 20. Again, the pressure does not change on the entire low side of the system, so let's go ahead and fill those in. Now, we do know that my temperature is going to change. Okay, so let's come over here where we know we're in the condenser. My pressure is 169. We need to find the temperature based on the 169. So let's come to R409A, which is right there. Okay, now 409A is one of those weird refrigerants that has a bubble point and a dew point. Okay, so it has a temperature glide. Let me get rid of my other ones there. Now, when we're talking bubble and dew point, okay, the bubble point is my liquid side, okay, so my high pressure side. Dew point is my low pressure side. Okay, so in this case, remember, I want to find my, 169 PSI. Okay, so we are going to look on the dew point side. That's the left-hand column. Okay, so 169 PSI. Sure I'm on the right spot. Okay, which is going to be right around 122 degrees. Okay, so I'm going to go ahead and use 122 degrees. So let's come in here. Now, while I'm there, I'm going to go ahead and find my 20. That's going to be on the bubble point side. Okay, because again, we have a temperature. So it's giving me a 20 PSI. So let's come over here, scroll up, and we need to find my 20 PSI, which is going to be right around, I'm going to call it 9 degrees. Okay, so my evaporator temperature is 9 degrees. Some of your pressure temperature charts or the apps on your phones might have a much more accurate, so you don't have to figure out in the middle of a chart. Okay, I'm not going to put my 9 degrees in this temperature right here because I have superheat. So we take our 9 plus 12 and we have 21 there. Okay, because that's right there. That's that last point before the compressor. And we have gained sensible heat. Now, throughout the cycle, I do not have superheat at all. And I also do not have any subcooling on the low side of the system. So we can fill those blanks in just with a blank. Okay. Now, over here, I have a temperature of 169. That's that point right there. Okay. I know that my condensing temperature is 122. So the difference between my condensing temperature and my measured temperature at point 1 is my superheat. Okay, so 175 minus 122 is 33 degrees, or oops, helps if I, 53 degrees, sorry. Okay, I do not have any superheat throughout the rest of the system. there because it's in the condenser coil. I don't have any superheat on the liquid line, or I better not have any because I'm still losing temperature. Now, TP4, remember we have subcooling. So right there, okay, TP4. So I now have to take my 122 and subtract 14. So we go over to my handy calculator and I find my 108 degree temperature, because again, my condensing temperature is 122. I know the sheet is telling me that I have a 14 degree subcooling. So my point here, the temperature right here at TP4 is 14 degrees cooler than my condensing temperature. Okay, throughout the rest of the system there, I do not have any subcooling. So let's go ahead and just put a dash in those blanks. So again, all we're asking on these worksheets is just to remember the basic refrigeration cycle, remember where superheat and subcooling is, and use the numbers given to find those different values. And again, just to make it easy, if you can remember where your points of pressure change is, okay, you can easily figure out the high and the low side of the system. So I hope that helps a little bit with the refrigeration worksheets.